Hello and welcome back. This video will serve as a little bit of a correction to the videos I made for 9.1 and then 9.2. I misspoke about some of the confidence intervals that we're using to test hypotheses. So when the null and alternative hypotheses look like this for comparing to, let's say, either means or proportions, what we'll see here is that our alternative hypothesis is that the first mean is simply less than the second mean, or the first mean is greater than the second mean. So what we're really testing is one bigger than the other. And this is called a one-tailed test. So when we look at our normal distribution or t-distribution, what we're testing is does the data from the sample seem unusual, and if we're just looking to see if one is bigger than the other one, we are either looking at sort of a tail that happens either far to the left for this guy, or for the other one, we're looking at a tail far to the right. We're seeing, okay, is mean 1 so much less than mean 2 that it seems unusual, and it would be at the far end of the spectrum, or vice versa. We reject the null hypothesis when our test statistic ends up in this little region, either far to the left or far to the right, and this is called the critical region. And the further we are away from the center of a normal distribution, the more unusual things seem. So if we get some stats that seem very, very unusual, we can go, well, we made a false assumption, so we get to reject the null hypothesis. So that's what hypothesis testing is about. So in particular, when we are calculating a confidence interval, what we're doing is we're listing all the values that aren't in the critical region. So for instance, up here, if we were going to be listing a confidence interval for this, we would be listing off all of the values that would correspond to getting a sample that lies in this area. So if our sample sort of lies in this area, okay, things seem reasonable, and we can't really deduce very much. Our assumptions seemed sound. If we happen to get a confidence interval and our test statistic sort of lies outside of that confidence interval, well, then things would have probably would be unusual. But you'll notice that a confidence interval is a range of values, and it has an empty space to the right, it has an empty space to the left. So our significance level just corresponds to 1/2 of that. So we also have a significance level. We also have, this is a symmetrical shape. So alpha also appears over here. So the confidence level, the area that's left over, is going to be 1 minus 2a. The area under the curve is 1. The probability of anything happening is 1. The probability of something happening over here is going to be alpha. The probability of something happening over here is alpha. What's left over is 1 minus 2 alpha. So in a one-tailed test, so this is still for one-tailed tests, our confidence level is going to be 1 minus 2 times the significance level. Let me quickly go through an example. So let's say that we want to test whether, say, men are taller on average, or women are shorter on average than men. So we perform a hypothesis test. So the mean height of men and women are compared via 2 samples of size 100. So we measure 100 men and 100 women. The sample mean for the men is 70 inches, but the standard deviation is 3 inches. for the sample of 100 women. We measured them, and their sample mean is 64.5 inches, but the standard deviation is 2.5 inches. So we just want to test the claim that women are shorter than men on average using a confidence interval. So we're going to create a confidence interval, and we'll use a 0.01 significance level. So let's write down our null and alternative hypotheses. So let's say that mu1 is going to be the population mean for men, and mu2 will be the population mean for women. What we're testing is whether or not mu1 is going to be greater than mu2, the average height of men is greater than the average height of women, or whether or not they're going to be equal. This is a one-tailed hypothesis test. So when we draw our little, so this is technically not a normal distribution, a t-distribution. Again, this is going to be a one-tailed test. So this area down here is going to correspond to 0.01. And if we were using the p-value, we would be directly using that. However, if we want to use a confidence interval, our confidence interval is going to be this area in between. We want it to be symmetric. So this area over here is also going to be 0.01, and this is going to be 0.98. So what we need is a 98% confidence interval. And we can construct that. So let's come over to StatCrunch. If we come to statistics, we are comparing means. So we want to use the t-scores, the t-statistics. We have two samples. We don't have the individual data points for all of our men's and women's heights, so we're just going to do this with summary, and we can input everything here. So the sample mean, let's do the men first. That was 70 inches. The standard deviation was 3, and we measured 100 men. For women, we found it was 64.5 inches with a standard deviation of 2.5, and we also measured 100 women. We are not going to pool the variances because we're not going to assume that both men and women have the same standard deviations. They were different in our samples, for instance. We're not going to perform a hypothesis test. We want to perform a confidence interval. And our confidence level, which we just found, was 98%, as in 0.98. We can then compute this, and we get all of our statistics right here. So we're looking at the difference between the two means, and the difference is in a confidence interval. The lower limit of the confidence interval is going to be 4.58, and the upper limit is going to be 6.42 if we round. So let's come back here, and our confidence interval was from 4.58, 6.42, 4.58 up to 6.42. So writing this again using this notation, this would mean that the difference between mu1 and mu2, as in mu1 minus mu2, is going to be somewhere between 4.58 and 6.42. And we'll notice that 0 is not inside of this confidence interval. So our statistics tell us that mu1 minus mu2 is confidently not 0. So we get to reject the null hypothesis, and we can conclude that the mean height of men is greater than the mean height of women. So that's all there is to it. I was mistaken before about the confidence level. I had mistakenly said that this should be a 99% confidence level. It is in fact 98. We have the significance on both sides. For a two-tailed test, this is not the case. So if we're just testing if mu1 is not equal to mu2, the confidence level is just 1 minus alpha. So with a two-tailed test, this is a poor drawing of a normal distribution, but oh well. For a two-tailed test, our alpha corresponds to the sum of both of those areas already, because we already know that it's a two-tailed test. So the area in between is just going to be 1 minus alpha. So two-tailed test is your confidence level is just going to be 1 minus alpha. For a one-tailed test, our confidence level is going to be 1 minus twice the significance level.